Hi class. I had two students come to go over the exam, and after finishing going over the exam, I thought it might be a good idea to go over the entire exam for the whole class using a video. So for problem 1, we have colleges and universities are beginning to realize if they raise tuition much higher than current levels, student demand drops to dangerously low levels. Ivy Leaf University has found that when they raise their $50,000 a year tuition by 5%, 15% of their 10,000 students decide to transfer. So here we have P1 is $50,000. P2 is $50,000 times 1.05 because the price increased by 5%. That's 52,500. The original number of students at Ivy Leaf University is 10,000. They lose 15% of their 10,000 students, or 1,500 students, so quantity 2 is 8,500. This is a price elasticity, an arc price elasticity problem, so we have Q2 minus Q1 over P2 minus P1 multiplied by the average P1 plus P2 over Q1 plus Q2, or Q2 is 8,500 minus the original 10,000 students over P2 is 52,500, subtract the original 50,000. Sorry about that. 52,500 minus 50,000. Your professor made a mistake. Or 2,500, we have a negative 1,500 over 2,500 multiplied by P1 plus P2 over Q1 plus Q2, and we get a price elasticity of 3.32 negative. Well, what does that mean? That means we have a negative 3.32 price elasticity, which is price elastic. A 1% increase in price is going to lead to a greater than 1% decrease in quantity. I also asked you about, is this a good revenue decision for Ivy Leaf University? And indeed it's not. Anytime you have a price elastic good and you increase the price, your final revenue will be less than the original revenue. You can check this by multiplying P1 times Q1, and that was 50,000 times 10,000, and you will see that that's greater than 52,500 times 8,500. And we can just check the math and do 50,000 times 10,000 and compare that with 52,500 times 8,500. And indeed, this second number is less. This is less than this. So we have a price elastic good, and it's not a good revenue decision. Now, what kind of a good is an Ivy Leaf education? It's price elastic. It isn't a normal good. It's not a luxury good. Those kinds of goods have to do with income elasticities and not price elasticities. Indeed, we cannot separate out the substitution effect and the income effect in this total effect, so we cannot say just based on this calculation whether or not we have a normal good or a luxury good. All we know is that we have a price elastic good. Moving on to the next question. It's about garbage. The Town Council of Lake Wobegon wants to increase recycling by their residents. Currently, the garbage truck rolls through once a week, but there's no curbside recycling. They have an idea to institute a policy that would charge by the pound to get rid of garbage. Right now, it doesn't matter how much trash you can stuff into a bag or garbage can. Before the policy change, the average number of pounds demanded was 100, and I gave you 15 cents a pound. After the price increase, the average number of pounds of garbage is 90, and the price is 30. I also say income is 100, and the price of other goods is 1. This sets up the problem. All the information you need. So the next part of the problem says, what's the budget constraint? Well, the budget constraint is income is equal to expenditures on one good plus expenditures on the second good, or 100 is equal to 0.15 times 100. Here we go, original prices and quantity, plus 100, or 1.0, which is $1, times X, because we don't know. But you could actually figure this out and identify what the equilibrium is. Now, at the new prices and quantity, income hasn't changed. It's 100, 30 cents a pound. Demand, 90 pounds of garbage, and the price of other goods hasn't changed. That's the budget constraint. The budget line, as we know, is Q other goods is equal to Y over the price of other goods minus the price of trash over the price of other goods times the quantity of trash, or 100 over 1 minus 0.15 over 1 times 100 at the original prices and quantity, and 100 over 1 minus 0.3 over 1 times 90, the new prices and quantities. Now, how to graph this? I am going to get rid of this and start again. We'll add a new slide, and we'll see if I can graph this better than I did the first time. So here on my horizontal axis I have trash, and on my vertical axis I have all other goods. I know that the maximum quantity of all other goods is Y times the price of all other goods, or 100 divided by $1, or 100. Before the price increase for trash, I know that the maximum quantity of trash is 100 divided by 0.15, or a very big number. That's like 666 pounds of trash. And I can graph my budget line. Now, you know from the problem that at these original prices, the consumer demanded in equilibrium 100 pounds of trash. So what happened? I raised the price from 15 cents to 30 cents. So at 30 cents a pound, I demand maximum I can get is 333 pounds of trash. But I know, based on the problem, that the new equilibrium quantity at 30 cents a pound was 90 pounds of trash. Now remember, the price of trash increased. The budget line rotates around the maximum quantity of the good whose price doesn't change. It's still 100 over $1. Rotates in because the price has increased. The next part of this question asks you to decompose this into a substitution and an income effect. Now we know that the total effect is moving from 100 to 90. I also gave you the idea that trash is a normal good. Remember, with normal goods, the income and substitution effect go in the same direction. So let's see if I can decompose this into an income and a substitution effect. So how do I draw a diagram to identify the income and substitution effect? I first compensate the consumer with income that they didn't have before, draw a line tangent to the original indifference curve, parallel to the new budget constraint. And label that Q star. The substitution effect says, trash became more expensive, I substitute out of it. The income effect says, as real income decreases, and it's a normal good, I'll take less of it. So the income and substitution effect go in the same direction, I've decomposed it into a substitution and an income effect, and the consumer moves from demanding 100 pounds of trash to 90 pounds of trash. So therefore, raising the price of hauling away trash actually decreases the amount of trash produced. And this is a good decision for Lake Wobegon. I'm not going to go over the matching, but I will quickly go over the short answer. You had a choice. You had a choice to do some short answer. We had poverty alleviation programs as question 1 in section 2, and it has to do with giving away transportation vouchers. So what a voucher does is it says that I don't only have income to spend, I have income to spend only on transportation. So let's say I have transportation on my horizontal axis and all other goods on my vertical axis. I know that my budget line, I need 2 points, income over the price of other goods, and original income over the price of transportation. And I can say it looks like this. Now, what kind of constraints or unconstraints does this household face after I give you transportation vouchers? Well, the vertical axis does not change because my income that I can spend on all other goods is the same as it was before. However, I can spend more on transportation because I have these vouchers good for transportation. But prices haven't changed. So what this means is I have a discontinuous budget constraint. This consumer cannot consume any more than the maximum quantity. If I had given them income, there was the possibility that they can consume actually more other goods and less transportation. That's why we do targeted programs. We would like consumers to be able to consume more of the good that we think is in their best interest. The last question has to do with the price of beans. The demand for beans amongst poverty-stricken people increases when the price of beans rises. Are they exhibiting behavior explainable by the economic theory of the household? The answer is yes. The answer is if a good is so inferior that the income effect drawing them into eating beans is greater than the substitution effect, saying beans are more expensive, I eat less beans, I can end up with more beans after a price increase. This is a Giffen good. Well, there you have it. That's exam 1. I hope this was helpful, and I'll see you next time.